Today's notes are on balancing chemical equations. This is learning target number 11 for the chapter. This is something that you've done many times before. Please feel free to stop the notes at any time if I'm going too fast, because again, I'm just recording. I'm not trying to keep pace with you. So that's one of the beauties of recorded notes. You can pause as needed for yourself. Okay, so our first thing is we're going to talk about why do we balance equation. It's really the law of conservation of matter that makes us balance equations. Remember, matter cannot be created nor destroyed in an ordinary chemical reaction. In other words, what goes into the equation must come out. We have to have the same stuff on the left of the equation, the same atoms over on the left, the reactants, as we do on the right, the product side, in every single equation, and that's why we balance equations. Now, when we balance equations, we only use coefficients. And again, the coefficients are those big numbers that we place out in front of the formula as we are balancing the equation. So example, if I put a 2 out in front of a carbon dioxide balance, that number out in front is the coefficient. Same thing with the 4 in front of the water. So I may only change those. You may not change, edit, add, modify in any way the subscripts. Remember, sub means below. Those are the numbers that are in and make the chemical formula. So you can't change those, or you change the formula itself. So those little numbers within the formula, like the 2 in the CO2 or the H2O, I can't add anything, I can't delete anything, I can't edit anything. Those numbers have to stay the way they are. In all of your equations, the formulas are completely written. You're not trying to balance anything, so you cannot change those. If you were writing a formula from scratch, then you can place subscripts in, but only to help balance the charges. Now, some things that I like to do. First of all, I always try to balance by inspection first. That means just eyeball it. Look at the equation, see if you can balance it just by looking at it. If that doesn't work, then we're going to employ another method where we list all the atoms and polyatomic ion groups and keep track of the numbers of each. Sometimes just in an equation where there's a lot of stuff going on, it's helpful to do that. I always try to do oxygen last if possible. It makes a big difference, and oxygen is usually the one that causes trouble and makes things sticky in a balancing equation. If you ever end up with an even-odd situation, you balanced everything and you have one atom, and it's usually oxygen, that's even on one side, odd on the other side, then you need to just multiply the odd item by 2, double it, and then rebalance everything else, and things will straighten out. So you're going to see some examples of that today. Next, you can keep polyatomic ion groups like nitrate, sulfate, phosphate, any of those things. You can only keep them together mentally when you're balancing and or physically when you're balancing if they appear in the same form on both sides. So if you have an NO3 on one side but no NO3 on the other side, you can't keep them together. You're going to have to split those atoms up and think about them individually. The last thing you want to recognize is that a coefficient becomes a multiplier. So when you're keeping track of your numbers of atoms, that big 2 out in the front, like this one, of the magnesium means I have 2 of everything behind there. So I have 2 magnesiums, but I have 2 times 4 nitrogens. And then I have to multiply these two together. I have 6 times 2, or 12 oxygens. So keep that in mind. Sometimes students have difficulty balancing equations because they forget that they have to multiply those numbers together. So the coefficients and the subscripts multiply together to get you the correct number of atoms. So let's try some examples. So here in this first one, we're just going to inspect this. We have one copper, one silver, one NO3. I see that, I recognize that as a polyatomic ion group, so I'm going to check. Oh, there it is on the other side, but I have 2 over here. So then now comes in my issue. I'm going to grab a pencil, and to fix that, I need to put a 2 out in the front. Again, I can only place numbers in the front. So now I have 2 nitrates, but I've created a new problem for myself. I now have 2 silvers, which is easily remedied by putting a 2 out in front of the silver. So now double check, one copper, 2 silver, 2 NO3s, and 2 NO3. So this one is balanced. And I just did that just by eyeballing, going back and forth, keeping mental track. All right, here's another one. This one looks pretty simple also. So we have 1 iron and we have 2 irons, 2 oxygen, 3 oxygen. Okay, so let's employ the same method. We'll just try a little inspection here. We're going to put a 2 out in front of the iron to get us started, so that balances the iron. Again, we're keeping oxygen last, but now we get to this even odd situation. We have 2 oxygen. No matter what I put out here, it's going to stay even. This guy over here is one that's giving us the trouble. He's odd. So I'm going to double, put a 2, but now I have messed up what else I had balanced, but that's easily fixable. We can go back, so we're going to cross off that 2. And now we have 4 irons and 4 irons. We have 2 times 3, we have 6 oxygens. So to get 6 oxygens on this side, we will need a 3 out in front. So this one still was pretty relatively easy to balance to get our correct answer of 4 iron, 3 oxygens, and 2 iron oxides. Now, this last one is a little bit more difficult. There's a lot more going on in here. So this time we're going to employ the list. So I'm going to move this down a bit, give myself some space, and make a list. So I have carbon atoms, I have hydrogen atoms, and I have oxygen atoms. And basically what you do is just keep track of what you have on the left and what you have on the right. So if it helps, draw a line. And I apologize, it looks a little sloppy, but I'm writing on the trackpad with my finger as the pencil. So I have 4 carbons on the left and I have 1 on the right. I have 10 hydrogens on the left and I have 2 on the right. And I have 2 oxygens on the left and I have 3 on the right. 2 here and 1 here. Got to put those together. Okay, so again, oxygen last, try everything else first. So I have 4 carbons, so I'm going to start by putting a 4 out in front of the carbon dioxide to try to get that to balance out. So that changes this to a 4 also. But now I've also changed my oxygen. So I have 4 times 2, I have 8, plus 1 over here on the water. So my oxygen count is 9. Make sure you update everything each time that you do any balancing. So now I'm going to tackle the hydrogens. I have 10 over here, so to get 10, I'm going to put a 5 in front of the water. So that will give me 10 hydrogens. Again, I have, unfortunately, messed up my oxygens. So go back and start from scratch in your counting every single time. So I have 8 oxygens, 5 oxygens. That gives me a total of 13 oxygens. Okay, everything's balanced. 4 carbons, 10 hydrogens, except for the oxygen. And here again, we've got an odd number of oxygens. We've got a 0 or 1 oxygen here, and 5 out in front of that. So that one stays odd right now. And over here, no matter what I do, I can't get an odd. I can't get 13. So I am going to have to double this guy here because that's the one that's causing the problem. So I need a 10, which means I now have 20 hydrogens, and I have 10 plus 8 more. I now have 18 oxygens. Okay, so I'm going to fix that on this side. I need 20 hydrogens, so I'm going to put a 2 here. My carbon count is now 8. Hydrogens are 20. And I've messed up my carbon, so I'm going to fix that. I really need 8 of those. So instead of a 4, I'm going to want an 8 out here also. And everything again is balanced. So now, hopefully, I can work my way through. I do need to double check my oxygens, however. I have 16, 8 times 2, plus 10 times 1. I have 26 oxygens. Oops, weird 6, sorry about that. All right, and so then on this side, to get 26, I am going to multiply by 13. 13 times 2 gives me my 26, and now everything is balanced. So now, last but least, we are going to take a look at different types of reactions. And some of your questions in the homework, they're also going to ask you, what type of reaction do you have? So we're going to take a look at the different types. We have combination or synthesis. To combine or synthesis means to put together. So we have two or more reactants combining to make a single product. So here's an example. We have two things on the left, we get one thing on the right. Combination, to combine, to put together, to synthesize one thing. Decomposition, when things decompose, they break down. So here we have a single reactant breaking into two or more parts. So something big on the left breaking up into littler pieces on the right. Combustion is the next type. Combustion means burning reactions, okay? People tend to think combustion, explosion. Yeah, sometimes there are explosions that come with burning. But combustion just is a fancy word that means burning. So it's usually going to involve oxygen because we know we need oxygen for burning to take place. The common products are carbon dioxide and water. Now, because of that O2, this is going to be a common spot where you're going to see that even-odd situation. So be aware of that when you have to do that. But anytime you've got, especially a lot of carbons and hydrogens plus oxygen, and then carbon dioxide and water, it's a combustion reaction. And then the last one is precipitation slash displacement. Now there can be single displacement or double displacement. We're not going to worry about that necessarily, more worried about the precipitation displacement thing. So precipitation, we know precipitation is when things fall to the earth, like snow, rain, sleet. Same thing happens in chemistry. When you mix some things together, sometimes something falls to the bottom of your beaker or a test tube. So it precipitates, it settles out, it falls to the earth like snow or rain or sleet. So we see a solid substance forming and it settles out to the bottom of your container. And we can see that by looking at these little subscript notations down here. So this one's aqueous, it's in liquid form, aqueous liquid form. This one is a solid, so that thing would have formed in there when we mixed these two reactants together on the left and formed this insoluble solid. We're going to be talking about that in chapter 4 a lot more. But anytime you see a solid on this side and there were no solids over on the other side, you have a precipitate, something settling to the bottom. All right, the rest of the time today then is yours for homework. Please check the assignment on Edmodo. Have a great day, and I will see you tomorrow. Bye.